In this video tutorial, I will be showing you how to create a professional level, high quality, and high resolution landscape in Unreal Engine 4 in just a few steps and a few hours. The only software that we require is TerreSculptor Professional Edition, Photoshop, and Unreal Engine 4. Some of this tutorial can also be accomplished with the free TerreSculptor Standard Edition with limitations on file format support, file resolution, and an alternate landscape material will have to be designed. For this tutorial, I have located a random USA coordinate 1 meter digital elevation model from the USGS NED online repository. I chose 1 meter resolution since that matches perfectly with the default 1 meter landscape vertex resolution. This gives us a landscape in Unreal Engine that is of the same resolution as the real-world location. The source digital elevation model was in GeoTIFF format, which can be imported directly into TerreSculptor Professional. You always want to get digital elevation model data that is in 16-bit or floating point format. This includes such file formats as BIL, BT, ESRI, FLT, HGT, GeoTIFF, and others. TerreSculptor Professional Edition can import more than 100 file formats, including many digital elevation model formats. 8-bit grayscale and 24-bit or 32-bit color formats will never contain the highest quality of elevation data. A true 16-bit file contains 256 times the elevation data as an 8-bit file. Using an 8-bit file for elevation data is like using 16 color images for textures. The source digital elevation model is not at one of the recommended Unreal Engine 4 landscape sizes, so we will either crop or resample it down to 8129 by 8129, which is the largest single landscape recommended size. If we crop, we maintain the same resolution between the 1 meter digital elevation model and the landscape. If we resample, we slightly decrease the equivalent resolution. Always use a recommended Unreal Engine 4 landscape dimension size. These resolutions were chosen because they exhibit the best engine performance. TerreSculptor includes a UDK landscape sizes tool that allows you to easily look up any size, any recommended size, and any common world composition size. If the terrain height map is not the full 0 to 100 altitude range, then choose the normalize function. This is the final height map in TerreSculptor Professional. Note that I have set all of the typical software settings, including zoom extents located on the toolbar, terrain LOD mode to a setting of normal located on the toolbar, auto range color set located on the toolbar, and I hid the main world grid using the Scene Objects panel. In order to visually view the height map as how it will match up in Unreal Engine 4, go to the Terrain Properties tab and set the XZ spacing and Y spacing both to 100. Which is 100 centimeters per vertex. Export this final 8129 by 8129 height map to 16-bit PNG format, giving it a file name of hlandscape8129.png. The H prefix is for height maps. Now we will create all of the weight maps that we require for the Unreal Engine landscape material. We will be using a splat map type material which provides for 3 defined weight maps plus a base weight map. So we have to decide on what 3 terrain features we wish to highlight with different textures. I often like to separate terrain features by low altitudes, which is the water, by flat slopes, which can be dirt or fields, by steep slopes, which is the rock faces, by water runoff, which is part of the erosion mechanism, and leaving the base splat map weight map to be the default terrain texture such as grass. So let's create the flat slopes weight map. On the TerreSculptor Professional Extractor menu, choose the slope mask device. We want flat slopes, so leave the minimum degrees at 0, set the maximum degrees to 1, and a fall off of 1. Then save this weight map mask as W slope flat 011 in 8-bit grayscale PNG format. The W prefix is for weight maps. Let's create the steep slopes weight map. We already have the slope mask device up, so we simply make the required property changes and save the file with the new name. We want steep slopes, so set the maximum degrees to 90, set the minimum degrees to 20, and a fall off of 10. Then save this weight map mask as W slope steep 20 90 10 in 8-bit PNG format. Now we need to create the final weight map, which is the water erosion runoff. This weight map mask is created by running a hydraulic erosion device pass over the terrain height map and collecting the water flow information that is automatically generated in the device's hydraulic water mask. We won't be keeping the erosion changes to the height map, we only want the mask that this algorithm automatically generates for us. On the hydraulic erosion dialog, set the time to 500, enable the Save the Masks to Disk checkbox, choose 8-bit PNG format, and specify the folder where you want the masks automatically saved when the erosion has completed. It is highly recommended that you have a high-end computer to run any type of erosion simulation, since they perform many trillions of calculations on a terrain height map of this size, so these algorithms can literally require hours to complete. On my 12-thread i7, the hydraulic erosion required about 20 minutes to complete. Now that the erosion simulation is complete, we only want the water mask file that it generated. We do not save the modified height map. Before the water weight map mask is ready for use, we must do a bit of editing on it. For this step, I will be using Photoshop. This type of mask and weight map editing will soon be available directly in the upcoming mask editor in TerreSculptor Professional, which is designed specifically for editing masks and weight maps for material setups. Open the water erosion weight map mask in Photoshop. On the image menu, choose Adjustments, Exposure, and set the exposure to 3, offset to -0.5, and gamma to 0.3. Save the modified file as W hydraulic water mask PNG as an 8-bit PNG. Back in TerreSculptor, we will now create the required splat map for our Unreal Engine 4 landscape material. On the Tools menu, choose the Mask Splat Map Creator. Set the format to 32 bpp RGBA since we will be creating a 4-plane splat map. Set the mode to priority since we want any blending to be prioritized from channels R to G to B to A. On the Mask 1 Red channel, open the W Hydraulic Water Mask file since we want the erosion water texture to have the highest priority in the blending. On the Mask 2 Green channel, open the W Slope Flat 011 file since it is the next priority blend that we want. And on the Mask 3 Blue channel, open the W Slope Steep 209010 file. The weight information in the Alpha channel is automatically calculated by the Splat Map tool. Save this Splat Map file as wsplatmap_water_flat_steep.png. We should now have a list of asset files that we will be using in Unreal Engine 4. Launch Unreal Engine 4. On the Project browser, go to the New Project tab and give the project a name such as HQ Landscape Demo and click on Create Project. Create a new folder and call it Landscape and double-click on that folder to go into it. This is where we will be saving all of the assets. Click on the Landscape tab on the left and select the Import from File option. On the Height Map File text box, click on the ellipses button, navigate to the height map file that we saved previously and open it. Verify that the landscape properties are correct. 8129 by 8129, 127 by 127 quads, 2 by 2 sections, and 1024 total components. Click on the Import button. We now have our initial landscape loaded. Click on the Place tab on the right and select the volume set. Drag a light mass importance volume onto the static mesh platform. Set its location properties to 000. That is all that we will do with that actor for this demo map. Drag a post-process volume onto the static mesh platform. Set its location properties to 000. Set its scale properties to 5000, 5000, 1000. In the exposure properties group, set the exposure compensation to -0.5, the min brightness to 1, and the max brightness to 2. Drag some textures that you would like to use for erosion, field, rock, and grass into the browser. I chose some textures from the Epic Demo projects. Also drag the Splat Map texture into the browser. Create a new material and call it M Landscape Splat Map. Save all of the assets and map to disk. The material that we're going to create is a fixed material with the Splat Map. This type of material does not allow for manual painting on the landscape. For this material, we will require 5 landscape chords, 9 texture samples, 6 height lerps, and 5 constants. The splat map goes into 1 landscape chord and texture sample pair, with the chord value set to the resolution of the landscape, which in this case is 8129. Each of the 4 texture pairs, diffuse and normal, go into a set of landscape chord and texture sample nodes. If you recall, in our splat map, we set it up as red as the erosion water, so we want a light dirt or gravel for this texture. Green is the low slopes or flat areas, so we want a nice path or field grass for this. Blue is the steep slopes, so we want a nice rock face for this. And alpha is the base splat map weight map, so we want the main texture for this, in this case grass. The RGBA texture samples cascade through 3 height lerps with the splat map channels used for the lerp height texture input. The lerp A and B are the texture sample or cascaded lerp from the previous lerp set, and the lerp transition is a constant with the value 0.5. I have also preset the material's metallic, specular, and roughness to constant values. Click on Save to save this material. You may wish to pause this video and look at the values and wiring of each section to get an idea of how this complex material is constructed. I will try to paste a clipboard copy of this material into the video comments. Just copy that text to the clipboard and Ctrl-V it into the material editor, then refill in the texture sample nodes. Now that we have our complex material created, click on the Landscape actor and assign this material to the Landscape actor's Landscape material slot. You may at this time wish to go back and adjust some of the splat map material setup. I recreated the extractor for the flat slopes at settings of 1790-10. I recreated the splat map and re-imported it into the engine. I also adjusted the material landscape chords to dirt 10, path 10, rock 50, and grass 10. This is what it looks like unbuilt. We will now do a few adjustments to the lighting and fog and do a lighting build. Set the atmospheric fog properties for sun multiplier to 20 and fog multiplier to 2. Set the light source properties for intensity to 5 lux and light color to 255, 240, 230. Set the skylight properties for intensity to 0.3 and light color to 255, 220, 210. Set the lighting quality to medium and perform a lighting build. This is the final built map. After a bit more tweaking of values and another lighting build, here is a quick video. This entire 8K landscape map from start to finish took about 4 hours, including the lighting builds.